presenting about Devel StatProfiler, which is a profiler. So, as everybody had here not used a profiler ever. But do you know what a profiler is? Okay, you probably have used event-based profiler like NYT-Prof, which records every single event which happens in the program. For example, it records every function call. In the case of NYT-Prof, the execution of every single line. So you get a very detailed profile which tells you everything about a single execution of the program. So Profiler uses a different approach. So it stops the program at periodic intervals and takes a stack trace. And this gives you some information about what the program is doing. However, it's approximate, and because it's sampling or statistical, so you don't get most of the information you would get with NYT-Prof. So, what are you going to get with StatProfiler? You get this, which should look familiar if you ever use the StatProfiler, but there is much less information. For example, here in the file list, in NYT-Prof, you get example timings and the number of times the subroutine has been executed. There you only get the number of samples, which is just an indication. I took this number of samples and I spent this amount of time, more or less, in subroutine. So, on top there is the frame graph. Again, it's like NYT-Prof. Does everybody know what a frame graph is and how to read it?
So the heat map?
No, it's the, well, sort of. So each horizontal bar is a single subroutine. The width of the bar is the amount of time spent in the subroutine. On the bottom of the frame graph, that is the main, the program name. So in this case, it's a, probably cannot read it, but here, this one is the new program. It's a .pl script, and then going up, and each function call is another rectangle on top of the previous one. So for example, here, this is the main program. These are the two subroutines which are called from the main program, and so on. So this gives you a visual representation of what the program is doing, so where it spends the time, and it's easy to see because it's visual. And there is also the possibility of drilling down. So for example, picking this subroutine, which is very small, so you cannot really see what it's doing. You only see spending 5% of the time it's calling something else. You can take a zoom, so it's slightly simple to see that about half of the time, well, a bit less than half of the time in this subroutine spent actually calling something else. If you want a bit more detail, you can go to the file list here on the bottom. For example, you can see click on the yes. So you have the annotated source of the program with the time spent on each line, the time spent calling other subroutines, and you have links to see which subroutines the params have been called for each line, and from which points in the program this subroutine has been called. However, as I said, you get much worse information than what you get from NYT-Prof. Because, for example, for NYT-Prof, you can see even the number of times a single loop has been executed. So it's very easy to spot why, not just where the time is spent, but also why. Because, for example, you can see if a subroutine For example, one time I found a caching bug because a subroutine was called way too many times because I had a bug in the cache. With this, you will never know if a subroutine is called too many times or not. So the only reason to use it is because it's fast. Now, fast doesn't really mean much. To give some numbers, if you use NYT-prof, your program can become up from 200% slower to 400% slower. With StatProfiler, it depends. In some benchmarks, it's 2 to 7% slower. In one-word production system, it's 1% slower, because the actual slowdown depends on exactly what the program is doing. Because if since it stops the program while it's executing, if it's using CPU, then it slows down more than if the program is waiting for I/O or for a database or something else. And anyway, you should measure what the actual slowdown is in your system. So, StatProfiler, since it's sampling, it requires a certain amount of execution time before it can give you some accurate data. For example, from our production system, it takes about half an hour to 1 hour to get something which is reasonably accurate for code which is executed often. For code which is executed less often, it requires even more time. So it's good to do continuous profiling of long-running application or applications which are run for a short time but very frequently. For example, a cron job which runs every minute, or a program which then runs for a very long time because it does a lot of processing. Now, how do you actually use the profiler? The basic usage is this: you just load the module. You don't even need any options, but it's probably a good idea to tell it where to write the profiling file, because otherwise you're going to write them in the current directory. And then there are some tuning parameters to identify the number of frames the program needs to sample, how to save eval source code, or how frequently it needs to sample the code. For Black application, you can use the previous approach, or you can use a middleware, which, in addition to loading the profiler, it also allows you to switch on and off the profiling per request, and it writes start and markers around each request. So, if you want, you can do aggregation based on for example, on the request to URL. Now, this is how you collect the data. To actually generate the reports, there is a simple command line utility, much like AmsterdamX.pm. You just give it the profiling files, it generates a report like the one we saw. Or there is you can do continuous aggregation. So while the profiler is running, or you want one by system and is creating more and more profiling files, those profiling files are collected, aggregated in a report which becomes more and more accurate as the time passes. Now, while this example code actually works, it leaves out a bit, some details. For example, you're not typically running the aggregation on the same host where your actual application runs, so you need a way to transfer the profile files from one point of your system to the other, which means, and the profile needs access to the source code, which means you need to have to transfer also the source code, which probably is a repository, so you need to have a way to communicate which tag is running in production, so the profiler, so the generator can use the correct report. And there is no documentation yet, because I extracted this code from our code booking during the weekend, so it's still a work in progress. If you're interested in using it somewhere else, pop me and I can explain a bit on how to set it up. And well, it works on Linux. It's tested on the micro.gsgi. It should work reasonably well on the Windows and Mac. I mean, I did some porting, so it might require some fixes, but it's not lost cause. Still, it's mostly used internally, so it's going to have some bugs in environments which are not exactly like the one we have. And that's it.
Is it pure Perl, or do you have any?
No, well, the collection part is written in C++. The aggregator is pure Perl.
Okay.
So when you collect, so continually you can collect more and more data and make it more and more accurate. Once you make a change, if it's to a script that you're running, it's to a web applications, to whatever, which might affect it, you would have to scratch the entire thing and start over, because otherwise the metrics would be skewed by a previous version, right?
What do you mean, a change on the source code?
Yes.
Well, it's not just the metrics with the script to get inconsistent results.
Exactly. So
Yes.
you would have to scratch the entire thing, start
Yeah.
over. And I'm assuming the continuous aggregation doesn't have some kind of way to signal that, well, now you're not collecting from that copy, you're creating a new copy because the old one.
Yeah, well, what it can do, well, the continuous aggregation does not assume to have access to a repository. However, if you code this in a repository, you can write in the profile file some metadata, which tells you which tag is the application running. So when you run the aggregator can fetch the correct the source code for the correct tag. So it generates the report using the correct source code. Does it make sense?
No.
Okay.
I mean, I know what you mean, but it doesn't make sense to me to do it.
Why not?
Because it sounds like it's hard. It's one, hard coding the behavior for Git and tags, and two, I would expect the StatProfiler to not do checkouts for me, but to just collect stuff and to be able to tell it how to store them, like to store by a certain name. I'll pick that it's a tag or something, so I can recognize it. I'll check out the right tag.
It's not hard-coded, meaning from the point of view of the profiler, you're just going to tell the profiler, here's some metadata, which one of the keys will happen to be a tag, but the profiler doesn't care, just strings. And on the aggregator side, the aggregator by default doesn't know what Git is. There is a mechanism to tell the source code which is reported under this prefix is actually in a Git repository. Use this class to fetch the code. So it's configurable enough that it doesn't know the source code is in a repository. It just needs to have a way. But when you set up on your specific environment, you're going to configure the profiler to save the Git tag, because you're going to know it's a Git tag, and the aggregator to know this path is a Git repository, fetch a tag from this metadata key. Makes more sense now?
Yes.
When is it on CPAM?
Because I'm lazy.
No, when?
Oh, when?
He knows why.
Yeah, no, I thought you asked it for the benefit of the others. Well, I don't know. Well, the profiler could be released on CPAN now, because it's. I will get a lot of failure reports, because I'm sure there is some time-dependent tests in here. The rest is not tested enough. Literally over the weekend, I ripped it out from I removed the booking specific parser from this. It's barely tested, so I could load the LCPAN now, but it don't make any sense. Let's say a couple of weeks.
Are you offering to help him? No? Oh, to put stuff on CPAN. You've got lots of stuff on CPAN.
Yeah, I'm already forcing peak.
So in the context of processing web requests, like, can the aggregation use some signature of the request to split the content? Like I might only be interested in aggregating the requests that I know are slow due to its parameter. So I don't need to always aggregate everything. Only aggregate some parts that I'm interested in.
Yes. Basically, when as I mentioned before, there is a way of putting start and mark around each request and emitting some metadata. Then, so for example, in the metadata you can emit the full URI for whatever you feel, and then in the aggregator, when it's reading the report for each section, you can tell all under which report this needs to be aggregated, and in case of that it not aggregated under any report, so it's effectively discarded. But there is no, and if you know that you don't want to profile a certain number of requests, you can even pause and unpause the profiler so it doesn't emit any data.
Like within a request cycle.
Yeah.